Ladies and gentlemen, boys and girls, welcome back to Engineering with the Absolute Idiot. Today we're going to be talking about these little guys. We're going to be making a smart version of one of these. First, let's talk about motivation. This is a long-term project I'm working on. The brain of the thing is going to be this little ESP8266. It's talking over I2C to some other stuff, and it's in the end going to be controlling this guy. So let's talk about what this is. This is a hobby servo motor. These guys will be found in big beefy RC airplanes because this one actually has a metal gearbox in it and it's considered the high torque version. And relative to the little tiny itty bitty servos, it really is high torque. But you know, everything's relative. Let's talk for just a second about what these are and how they're different from normal motors. A normal motor just spins around and around and around, and they're really good at doing that really quickly. On the other hand, this is a stepper motor. Stepper motors are very good at turning a very precise amount. So with extreme reliability, I can say, stepper, I need you to move exactly 1.8 degrees, and it can do that over and over and over again. However, it does not have any absolute position encoding. When I first start up my little thinking box, I cannot say I need you to move to the position 163 degrees. The best I can do is say I need you to rotate clockwise 163 degrees. So there's no absolute positioning, everything is relative. These guys are used on CNC machines, however, they need to be zeroed. There needs to be some other piece of hardware to figure out where the 0 point is so you can start counting steps past that. We're not going to get into how these work because that's not what this video is about. These guys are a middle ground between a normal motor and a stepper motor. They don't spin around forever. They can only spin, I think this one does something like 270 degrees. Some of them have different angles that they can spin. Some do 180, some do less than 180. Some can do almost a full revolution. I'm sure there's some that can do more. But they're all going to be just a few revolutions. But none of these cheap guys can spin around indefinitely. And it would kind of defeat the purpose if they could spin around indefinitely, since these guys are absolute positioned. What that means is that when my little thinking box here starts up, I actually can say I need you to rotate to 163.5 degrees, and it can do it. It knows the position of this shaft. There's some real clever trickery going on inside of these. We're going to be ripping it apart and looking at the insides. We're actually going to be modifying this one to make it smarter. But needless to say, they're using some real clever stuff in here, cheap components to do that. I'm going to go over this next part pretty quickly because it's not very important for this video. I might make other videos explaining more what I'm talking about. But let's talk about the motivation for needing to modify this. Hobby servos like this are controlled with a PWM, or pulse width modulation. You got 3 wires here. The shit colored brown one is ground. The kind of reddish orange one is plus 5 volts. And then the yellow wire is the control signal, which is a 50 hertz PWM. I might make another video explaining what PWM is, what pulse width modulation actually is. But for now, I'm just going to say it's a 50 hertz PWM, and you vary the duty cycle to change the position on these guys. However, there's no write back. So when my little thinking box says I need you to move to 163 degrees, it has no way of knowing whether mechanically this thing was able to do it. And that's actually an important thing for me for this project. In fact, I need to know the position of this thing even if it's completely disabled. So if a human is spinning it, I still need to know where this shaft is at. Now let's rip this thing apart and look at how it works, and then we'll talk about how to solve some of these problems and some of these requirements that I have. To disassemble anything like this, you're going to need a bright pink screwdriver. It's very important that it's that color. It just flat out doesn't work if it's the wrong color. This is the absolute cheapest screwdriver on the face of the planet too. So with the back cover off, you can kind of see what's going on here. You have a just standard brushed DC motor, dirt cheap, connected to a thinking box. And presumably this motor is hooked up to a gearbox up here, which I already know that it is. The last piece of the puzzle missing is how does it know where that shaft is at? Maybe it's got some kind of fancy, beautiful optical encoder in there or a Hall effect sensor. No, you guys, these things cost like $1. They most certainly do not. And this is where it gets a bit hairy because there are a gazillion little gears in here. Ta-da! So there's the mechanics explained. Motor comes up here. It looks like it connects to that tiny little itty bitty gear there, which goes to that one, 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 to that one. And by the time you've gone through all these gears, you've got some insane gear reduction ratio. So this thing's spinning like a bat out of hell, and this one's barely moving, which is good. That's what gives you that high torque. Do you know where my tweezers are? Shit. Actually, let's see if we can get these gears to stay in here. Ugh. Gross. There we go. That's it without the gears. And if we look closely, there's something interesting going on here. There's a little piece of plastic that comes up that rotates around. Let's keep taking this apart, see if we can solve that mystery. The motor should pull out of this guy. There we go. And now the mysteries of the universe are revealed. That's how they do position. Just a little cheapo potentiometer. Let's see if we can get this potentiometer out without breaking it, that is. And there you go. That's all there is to these little servos. Just a standard DC motor connected to this board. Both of these little guys are probably going to be for controlling the actual motor itself. They're basically going to be sending out high current pulse width modulations to the motor to make it spin at different rates and in different directions. Then we have a little dirt cheap potentiometer hooked up to the output shaft. This is how it reads the absolute position of the output, and it's also why these guys can't spin around forever. There are, of course, industrial servos that can spin around to their heart's content, but they use real expensive encoders like optical encoders or Hall effect sensors. This, however, is not what I would classify as an industrial servo. On the other side of the board, you can see the little thinking box. These are actually specialized chips for this application. And their job is actually pretty non-trivial. The math that they have to do to read the position out of this potentiometer and then know how fast to spin this motor without creating all kinds of nasty harmonic oscillations and shit like that. It's pretty complicated. I've read through some of it and understood absolutely none of it. Anyway, we don't really care about that. There's only a few things we want to do here. The first is we want some way to read the value out of this servo. And I would hypothesize that the center tap on the potentiometer is a really good way to do that. Now, I say that with a slight tongue-in-cheek because I've actually already done that for another project. That's exactly what this servo is. This fourth wire coming out here is just a tap on that potentiometer. However, because these guys operate at 5 volts, the swipe on the potentiometer is anywhere between something like a 0.5 volt and 2.5 volts. And tragically, the big shortcoming of the ESP8266 is that it only has a single analog pin, and that pin can only go up to 1 volt. Of course, the obvious solution there is just pull out 2 resistors and create a voltage divider. Unfortunately, I don't actually have 2 resistors that would work. And besides, I think there's kind of a fun project to be had here. And as a side note, one of the other requirements is that I can completely disable this servo so that it can spin freely. So here's the plan. We're going to embed one of these inside of the servo. This is a little ATtiny85. It's just a little programmable AVR. I'll be using the disgusting Arduino library to program it. What we're going to do is have this little 8-bit AVR generate the PWM to control the servo itself, as well as read the value out of the center tap of the potentiometer. All of that is going to be controlled over an I2C bus. So there's just going to be 1 extra wire coming out of the servo to control the entire thing. A few requirements here are going to be that this chip be removable so that I can reprogram it if there's a bug in my code or if I want to add in features, and that this potentiometer still function even when power to the entire servo has been chopped off. So we'll have to take a peek at how everything's wired up and make sure that this always has power. All right, enough talk. Let's go melt some lead. Thanks for watching, guys and gals. Go do some epic shit.